Semester Exam Review Packet, page 2. So page 2 has 3 proofs and some algebraic properties. So the first proof, I am given that J is parallel to K and L is parallel to N. So that is given information, and I want to mark that on the diagram. J is parallel to K and L is parallel to N. Use 2 arrows because it's not parallel to J and K. The next statement says angle 12 is congruent to angle 2. Angle 12 is congruent to angle 2. Well, I see that this has nothing to do with line N. Angle 12 and angle 2 are both along line L, and they are on alternate sides but on the exterior of lines J and K. So because J and K are parallel, angle 12 is congruent to angle 2, because when lines are parallel, that implies that the alternate exterior angles are congruent. Now my goal is to show that angle 12 is congruent to angle 6. So I look on my diagram, I find 12 and 6. So I've connected 12 to 2. So now I want to connect 2 with 6. So I think about these two angles. They are corresponding angles, so they don't have anything to do with line J, but 2 and 6 are corresponding angles. They're both on sort of the right side of their intersections, on the right side, on the right side. And so if I've got 12 is congruent to 2, and now I can show that 2 is congruent to 6 because L and N are parallel. 2 is congruent to 6. Angle 2 congruent to angle 6 because when the lines are parallel, the corresponding angles are congruent. So if 12 is congruent to 2 and angle 2 is congruent to angle 6, then angle 12 must be congruent to angle 6, which is what we're trying to prove. Angle 12 is congruent to angle 6. They're both equal to the same angle, both congruent to the same angle, so we are using the transitive property of congruence. Down to the next one. Okay. Again, we are given that J is parallel to K and L is parallel to N. That is the given information. I'm going to mark that J is parallel to K, L is parallel to N. I want to show that 10 and 8 are congruent. Angle 10 and angle 8. There's no line that connects those two, so we gotta use some other combinations to get there. Angle 10 is congruent to angle 4, and I see angle 10 and angle 4, those are not using line N, they're on alternate sides of the transversal, but on the interior of lines J and K. So those two angles are congruent, is when lines are parallel, that happens if and only if the alternate interior angles are congruent. Next, angle 8 is congruent to angle 4. Angle 4 and angle 8 are congruent. This doesn't use line J. K is the transversal, and angles 4 and 8 are the corresponding angles. They're both on the left side of those intersections. So again, because the lines are parallel, the corresponding angles are congruent. So if angle 10 is congruent to angle 4 and angle 8 is congruent to angle 4, that means 10 and 8 must be congruent to each other, which is what we're trying to prove. Angle 10 is congruent to angle 8. When two angles are congruent to the same angle, they're congruent to each other. That is the transitive property. Right, the algebraic properties review. Right, the reason we can draw the conclusion from the given hypothesis. So I start with 4x equals 20. I'm given that 4x equals 20, so why is x equal to 5? Well, if I'm going to solve this equation, I want to divide by 4 on both sides. So I'm using the division property. In number 2, I'm given that AB equals 2. The length of AB is 2 units. And then I'm also told that AB plus BC is equal to AC. Sounds like segment addition postulate. AB plus BC equals AC. So if AB equals 2, I can replace AB with 2. I can substitute 2 in place of AB and get 2 plus BC equals AC. The only thing that changed from the line above it is that I substituted 2 in for AB. That is the substitution property. Number 3, I'm given that A equals 3, and then I'm told that A plus 5 equals 3 plus 5. So what happened? What changed from the first line to the second line? On the left side I see that I still have my A, but now I have plus 5. On the right side I still have my 3, but now I have plus 5. So I'm adding the same thing onto both sides of the equation. So this is addition property. Adding the same thing to both sides. Number 4, x minus 1 equals 10. What happens to get to x equals 11? The minus 1 goes away, so how do you make that happen? Add 1 to that side, and so you'd have to add 1 to the other side to make 10 plus 1 equal to 11. Again, we're adding the same thing to both sides, addition property. Number 5, AB equals BC and BC equals CD. So if AB and CD both equal the same thing, they both equal BC, then AB and CD must be equal to each other. That is the transitive property. I would also accept substitution property. Number 6, x divided by 7 equals 2. And so what happens to make x equals 14? Well, I got rid of the 7. Instead of x being divided by 7, I had to multiply by 7 on both sides to get x equals 14. So I'm using the multiplication property because I'm multiplying both sides by 7. Number 7, y equals 9, and 6 minus x equals y. So if I substitute 9 in place of y, replace the y with 9, the rest of the equation hasn't changed, so I must be using the substitution property. Number 8, 3x plus 2 equals 8. And so the 3x stays there, but I got rid of the plus 2, so I must be subtracting 2, and 8 minus 2 is 6. so this is the subtraction property. Number 9, 7x plus 8 minus 2 equals 19 is given. What changed to make 7x plus 6 equals 19? The 19 didn't change, so I'm not doing something to both sides of the equation. 7x stayed, it's just that 8 minus 2 simplified to get 6. So I want to replace the 8 minus 2 with 6. This is just simplify. Number 10, AB is congruent to segment AB. If something equals itself, that is the reflexive property. Number 11, I see the parentheses are in the first line, but they're not in the second line. 3 times x is 3x, 3 times minus 5 is minus 15. The 60 didn't change. All I did was distribute. Distributive property. Number 12, FD equals AC changes to AC equals FD. The AC moved to the left side, the FD moved to the right side. It's the same equation, just the two sides switch places. That is the symmetric property. Number 13. So, looking at this two-column proof, start with the given information. Angle 2 is congruent to angle 3 is given. So I'm going to mark that on the diagram. Angle 2 is congruent to angle 3. Next statement says angle 1 is congruent to angle 2. I look at the diagram and I see that angle 1 and 2 are vertical angles. So that's the vertical angle theorem. So I'll mark that. Angle 1 and 2 are congruent. Transitive property is where we use those two equations to make a new one. Angle 3 is congruent to angle 2, angle 1 is congruent to angle 2. So if angle 1 and 3 are both congruent to the same angle, they must be congruent to each other. Angle 1 is congruent to angle 3. Now I see that angle 3 is congruent to angle 4. So I see those on the diagram, and 3 and 4 again are vertical angles, so vertical angle theorem. And so if I want to show that angle 1 and 4 are congruent, angle 1 is congruent to angle 4, I see angle 1 is congruent to angle 3, angle 4 is congruent to angle 3. If 1 and 4 are congruent to the same angle, then they have to be congruent to each other based on the transitive property.